D-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition, liftoff of the Falcon 9 rocket with science for today and for deep space exploration tomorrow. Falcon 9 has cleared the towers. Good evening, everyone. This is the post-launch news conference for our SpaceX CRS-8 mission tonight. And here to join us to give us a status on our launch and our mission is Kirk Sharman, manager for the International Space Station program at NASA's Johnson Space Center. Elon Musk, the SpaceX Chief Executive Officer and lead designer, and Hans Koenigsmann, the Vice President of Flight Reliability for SpaceX. And we'll start first with Kirk Sharman. Kirk?
All right, thanks. What a wonderful day. It's a beautiful day outside, a great day to launch a rocket, and we saw a great one. So I had the pleasure of being in the Mission Control Center at SpaceX, and I can tell you the folks were really excited, as were myself and Bill Gerstenmaier. And then we could hear the roar of the rocket. That was really cool. So after the launch, I got on the phone and talked to our colleagues in Houston, and there was a roar there too. So it was great to hear that. We're very excited to have our cargo and the Dragon safely on orbit, and we're very much looking forward to it to arrive to the ISS. I had a chance to speak to our mission control room in Houston, and all systems on board the ISS are ready to support the mission. And like I said, we're looking great, very forward to having the cargo and all the utilization on board ISS. Tim Peake will be grappling the Dragon at 6:12 a.m. Sunday Central Time, and Jeff Williams will be assisting him, and those crew members are ready to support that operation. And like I said, we're really happy to have Dragon up in space, and we'll be even more happy to have it on board ISS. So let me hand it back to you, and we'll hear from our SpaceX colleagues.
All right. Thank you, Kirk. Now to Elon Musk, our SpaceX CEO and lead designer.
Thanks. Well, it's great to be here. Just of course, we love doing a good job for NASA. So thank you for allowing us to deliver the cargo.
Mm-hmm.
Yeah, I think the mice are doing well. That's what I heard.
I'm not sure they're happy though.
I think they might be a bit confused.
Yes.
So it's probably not on their evolutionary path to be in zero G, but yeah, there's a bunch of astronauts on board. So the thing that was a little different about this mission on the rocket side was, of course, the rocket landed instead of putting a hole in the ship, or tipping over. So we're really excited about that, and the reason that's really important is about half of our missions will need to land out to sea. So any missions that are going to, particularly to geostationary orbit, or to escape velocity, anything beyond Earth is likely to need to land on the ship. And I thought it'd be worth just emphasizing that the reason for that is something that I think it would be good for the press to educate the public about, which is the difference between space and velocity, space and orbit. Like arguably the space station should be called the orbit station, because it's actually zooming around the Earth at 17,500 miles an hour, and it crosses the Atlantic in I think about 20 minutes or so. It's pretty speedy, and that's for example why there's such a short launch window, is because the rocket's got to get into orbit and kind of match the orbit with the space station, and it's it's moving so quickly that that orbital window is only open for a few seconds. So although a rocket looks like it's going up because it starts off vertical, actually it's going to very quickly turn and go sideways and go horizontal, and it's going to match that space station velocity of roughly 17,000 miles an hour. So basically, the rocket at stage separation is zooming out to zooming out to sea at an incredible velocity, and it doesn't have enough propellant to come back to basically zero out that velocity, boost back in the other direction, and then land. So in order to achieve effective reusability, if you want missions to go to high orbit or to escape velocity, you really need the ocean landing. I just want to make sure that was explained, and we can, in the Q&A, we can go maybe into a little more depth on that. But I think as things make progress, I think it is. I think it would be good for the public to know a bit about orbital dynamics, because it is a little counterintuitive. So anyway.
Thank you, Elon. And now to Hans Koenigsmann, our Vice President for Flight Reliability.
I just can fill in a little bit on the Dragon side. I talked to Mission Control on the way up. All thrusters have been fired, so we know Dragon's healthy. It's a good spacecraft. Everything's working. Our flight computers are running. Comm is working. Communication is working. The next thing that's going to happen is the opening of the GNC door, which then will activate Star Tracker. That is going to happen in about 2 hours and 15 minutes. And then the first orbital adjustment burn is going to happen in tomorrow morning. And docking with the space station then is currently planned for Sunday morning. It's, I think, 6 o'clock. Early in the morning at Eastern time. So everything is going well. It's an awesome day. I think the team, both on SpaceX side, on NASA side, and also on the 45th side, worked awesome together, and we did a great launch.
Thank you, Hans. And we'll take questions now. Please give your name and affiliation when the microphone comes to you. We'll start right here. It's with James here.
Sorry. Sure. Thanks so much. James Dean, Florida Today. Elon, do you think this booster, if it checks out okay, will be the first to refly? How soon could that be?
Yeah, that's a good question. I think that's likely. So the plan is to bring this booster back. Should arrive in port on Sunday, and then we're going to do a series of test fires. We're hoping to do that at the Cape, rather than transport it to Texas and then bring it back. So our thought is to basically fire it 10 times in a row on the ground, and if things look good at that point, we feel it's sort of qualified for reuse in launch, and we're hoping to relaunch on an orbital mission probably around May or June, so it's pretty soon. Let's say June. Try to recalibrate my timing expectations.
Just clarify that you could relaunch this booster within a few months.
Yeah. Well, I mean, in the future, hopefully, we'll be able to relaunch them within a few weeks.
Irene?
Thanks. Irene Klotz with Reuters. Congratulations, first of all. And with this, would that be a test flight, or would you hope to have a customer for that? And also, this has been kind of a long time coming for you. How do you feel about this, and were you surprised to actually see it stick the landing?
Yeah. We were just talking yesterday, went around the table on odds for success, and the consensus was about 2 to 1. So we thought it was more likely than not that this mission would work, but still probably 1/3 chance of failure. But we'd eliminated the reasons, the prior reasons. So we were confident that if it did fail, it would fail for a new reason. So as it turns out, there's a lot of reasons for rockets to fail. So But this was a beautiful day, and I think the circumstances were good. It's still quite tricky to land on a ship, and if on the video, I mean, the ship looks quite small relative to the rocket, so it's quite a tiny target. It's really trying to land on a postage stamp there, and it's moving, sort of translating and rotating. It's sort of like a carrier landing versus a land landing. It's a tinier spot, and it's moving.
The use of the reflight, would that be an actual paying customer on it, or would you do that just as an experiment to relaunch it?
We think it'll be a paying customer, but we got to have some discussions. So, yeah.